Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer and aspiring software architect.
And I'm Beej, the journeyman developer, sharing my journey in development.
Complete Developer Podcast is supported by listeners like you. We are now on Patreon at www.patreon.com/Complete Developer Podcast.
So you want to build a distributed system. This is not as simple as you'd think. And a lot of assumptions you might make in a simple program are very dangerous here. Not only are there issues like network failures, but there are a lot of things you've counted on that simply don't work the same way in a distributed system. The assumptions that you don't know you're making are the ones that hurt the most. So we're going to cover some of them in this episode. But before we get started, Will, what have you been fighting this week?
Dude, I got sick last week. I mean, we're kind of behind on recording. I got this sinus stuff, man, and it knocked me down. Mm-hmm. You go to bed at 2:30 in the afternoon, and then you wake up for like an hour, 8:30, and then you go back to bed, and then you wake up again, 8:30 the next morning, go in, go to the doctor, come home, go back to bed. And yeah, it beat the daylights out of me. And I still feel like I'm not entirely 100%. And it's been, over a week. So that was my last week, basically. Mm-hmm. How about you?
I am exhausted. Both my sisters were in town this weekend with their babies. Yes, I have two nieces almost a year apart. So I got to meet my 2-month-old niece for the first time and then spent some time with my 14-month-old niece. It was awesome, but exhausting. We went to the craft and art fair in Bell Buckle. Oh my goodness, dude, that thing was huge. Like, I was expecting it just to be around like the main shopping area because Bell Buckle is like this tiny little town. But no, like it spanned the whole town. Like, people rented out spaces on their lawns for vendors to set up. We were there all day Saturday and didn't even see the whole thing. It's that big. So it was really cool, but just a lot of walking around and carrying babies. Now, work-wise, I've been helping one of our senior developers with an older system that uses a much older version of Hibernate. The system was written by a vendor, and I kind of wonder if they're more Java developers than .NET developers. I'm seeing some of the Java patterns that I'm learning in school in their code that I'm like, that doesn't really make sense with .NET. So yeah, I'm thinking that. But since we're discussing distributed computing, I have something kind of cool for IoTs. Distributed computing has historically been relegated to academia, military, and large enterprises. Those distributed computing concepts will be critical to the success of the Internet of Things initiatives. This is an article about how IoT is making distributed computing cool again. For example, Ford Motor Company has invested over $180 million into Pivotal, a cloud-based software and services company. And the article talks about how the Internet of Things is going to bring distributed computing and kind of how it handles data to the forefront of development. It's really neat, and I'll have a link to that article in the show notes. Who's talking to us this week?
Well, we got an email from Joe saying, "Hey, Will. Hey, BJ. Just wanted to say that I really enjoy your podcast. I mainly listen to your show in the car as my commute to work is about an hour each day. I'm a software developer from Germany, currently programming in Java, Spring, Spring Boot, Hibernate, custom framework, and JavaScript AngularJS, still 1.x, unfortunately. And I find that your podcast is pretty much the most professional one out there, as your choice of topics is on par with the topics and problems I face every day in my job. Keep it up, guys." He also says, "P.S. I don't know if I'm eligible for that water bottle as I'm outside the U.S., but if I am, I would be very happy."
Joe, first off, thanks for the kind words. I'm learning a lot of Java right now as part of school. I use the .NET version of Hibernate in Hibernate. And the project I'm on, we started with AngularJS, so I'm still working in 1.x as well. So I don't think that's unfortunate. I mean, yeah, there's newer, cooler things out there.
I'm using Knockout, dude.
Yeah, I know. That's what I'm saying. But yeah, we put a lot of effort into the show. Both of us work in development during the day, so we bring a lot of what we do into it. And also, yes, you are eligible for a water bottle. Send us an email to neckbeards@completedeveloperpodcast.com with your contact information. I just sent out a bunch of water bottles, and one of them went to Denmark. But guys, if you'd like your very own Complete Developer water bottle, leave us a review on iTunes or comment on the website or any of our social media. We post all our episodes to Twitter, Facebook, LinkedIn, and Google+. We're also on Instagram and Tumblr. You can check us out each week on Facebook and Twitter Live, where we talk about what's going on in the tech world and answer listener questions. Or join the conversation anytime via Slack by going to slack.completedevelopernetwork.com.
Your employer may think that you can easily switch from building a regular old application to building a distributed system. You might think so as well, but there are a lot of nasty surprises that can sneak up on you if you're not prepared. Applications are getting more complex, and many developers try to deal with this fact by breaking the applications into smaller pieces that can be managed more easily, which is completely reasonable. That works well, but there are a few things that you need to keep in mind when you start building distributed apps. While the bad assumptions that we make when building distributed apps will not cause problems early on, they can definitely create some unpleasant surprises as your code ages. It's better to avoid them from the start.
So Will wrote this, and he pulled a lot of these fallacies from Wikipedia. The article did a really excellent job kind of laying them out. While it's a bit light on details, we'll discuss them based on sort of our own experience and explain why these fallacies cause so much difficulty. But before we get into that, we want to talk about why distributed computing is so different from non-distributed computing.
Yeah. So the biggest thing is it's basically really a function of, like time and physics. And it's expressed most succinctly in the CAP theorem, which suggests that there are 3 constraints on a distributed system, and that you can only, at most, meet 2 of these constraints. These constraints are consistency, network partitioning, and availability, which those are in the wrong order on the outline because it turns out that multi-threading sometimes bites you too. No, I'm just joking. I really don't know why they're in there in that way. So it should be consistency, availability, and partitioning. Because you can only have 2 of the 3, the other one will be the one that hurts you.
Now, because networks are unreliable at best, that means that you will be choosing between consistency and availability when there is a network partition. You're good the rest of the time.
Now, another item to consider is database design, and this is your ACID versus your base. Now, we've talked about ACID before, and that stands for atomicity, consistency, isolation, and durability. That's your typical database that you tend to use in not a distributed environment. So SQL Server, Postgres, like a lot of those tend to be ACID transactions. It either completely commits or it doesn't.
Now, base stands for basically available, soft state, eventual consistency.
Yes. And that's going to be stuff that you see more with your document databases. And I think there's probably relational models as well that can do it this way. I just haven't really seen a lot of that.
Let's say I haven't seen very many base relational.
They are starting to soften up a lot of, I think SQL Server, like the Azure stuff, I think I've seen some stuff with that. I know I have with Postgres that kind of changes the way the transactions work so that you can distribute stuff.
But essentially, the databases themselves are designed around the same sort of constraints that plague distributed applications.
Yeah, it turns out that time and physics are everywhere. Imagine that. And you can think of ACID as being extremely partition intolerant with the goal of keeping consistent and available. In other words, like I can't write to this table on this other disk because the disk is down. The transaction fails.
Right. Whereas base is partition tolerant at the expense of that perfect consistency.
And so that would be like, hey, write it to a queue somewhere, and if the thing's down, we'll push it over there eventually when it comes back.
So that kind of describes the differences between distributed and non-distributed computing. Now we're going to get into some of the fallacies that people have, known or unknown, about distributed computing. The first one we're going to talk about is the network is reliable.
The answer is no, it's not. Ever. We really know a lot better than to believe this, but we frequently code as if the network were reliable. Even though you and I both have home internet connections with Comcast, we both write code to go over the network that pretends like that's reliable. Even though we know better. In fact, it may be down right now for all we know.
Network calls are often coded as blocking I/O, especially when they are a few levels down in abstraction.
Yeah, so like you're using a REST client that sits over an HTTP client that sits over a network client that sits over, raw sockets. Well, if you're not controlling that and going, okay, well, this thing's not responding quickly, you're blocking I/O. In other words, you're waiting for something to come back before you do something to it. And if it doesn't come back...
Now, this also means that the calling application will often have to wait, sometimes indefinitely, for the result of that network call.
Yeah, passing -1 as a timeout, not such a good plan.
Wow, yeah.
It happens. And you feel like when you're building a desktop app, you treat function calls like they're happening on the same machine. When you abstract a function call to happen over a network, you tend to use function semantics to express that call, even though it's not happening on the same machine. So you'll make the mistake of making a network call and treating it like it's an in-app call. That's essentially what burns you here. If this happens on the UI thread, the app is going to stop responding. That's it.
Sometimes the problem is more complex than just the network.
Yeah. Well, the network is not just a single thing.
Yeah. Things like DNS services can cause problems if they start malfunctioning, resulting in sporadic failures.
Hey, speaking of Comcast, that's what happens here all the time. Yeah. My network will just get really slow, and I'm looking, and it's like, oh yeah, their DNS. Sometimes you can't ping their DNS server for a while for reasons.
And also, sometimes the network isn't down per se, but there are structural problems like malfunctioning routers causing periodic packet loss and slow transmissions.
Yeah, or you've got a misconfigured route where instead of it going, inside the network from, this router to this other router and then to the other machine, it goes through the router, out through the firewall, out through the open internet, back through the backbone, back down. And, if you've got a stupid route set up, like this happens all the time. And the more complex things are, the more likely this is.
Also, if your code has timing issues, this is when you'll find them.
This is when find you them will, actually.
Yeah.
Yeah. I can't, this is something I see a lot, and you see it in web apps, right? With like Ajax calls, where people are like, okay, I'm going to do this call, this call, this call, and then I'm going to assume that the timing is going to be correct in order.
Oh, yeah.
And no.
One of the biggest things that we dealt with, going from like .NET and Angular is like race conditions.
Yes.
Where it's, it's expecting this to happen and it's taking longer. So it's going on with the code and it's like, hey, this doesn't exist yet because we haven't gotten the info back from the API. That's something that we've had to deal with. Most recently, we have been migrating old data because we're rebuilding a system. So we've been migrating the data over, and a lot of the search functionality that we've built has worked great when there's like 5 records. It worked great when there was 1,000 records. When there's 10,000 though,
and they come across a slow network link. Yeah.
Yep.
I mean, it's like the old joke. I forget who told this one, but they said that next year for Halloween they're going to go as a race condition on November 1st.
Oh man,
that's like some deep nerdery right there.
Oh man, that's better than my out of work Silverlight developer costume. That's good.
Yeah,
that's good. You know what? Speaking of that, Halloween was just yesterday, and I dressed up as because I had a boot on my foot, so I was like, all right, how can I incorporate this? I wore my leather, and I dressed up as a injured biker, and so we have this party in the office with a Halloween, like a costume contest, and I walk in dressed like that, and one of my friends, she's a GIS expert, she looks at me, she's like, you can't dress up as yourself.
Yeah. Don't tell me what I can't do, lady. So the next incorrect assertion is that there is no network latency.
Like heck there isn't.
Okay, there's latency pulling stuff out of a CPU register.
Yeah.
Okay? It's just whether you notice it. It's always there.
Right. Even the fastest network call is far slower than a call on the machine.
In most cases. Like if you're still running an E-machine with Windows 98 and you're trying to play WoW, this might not apply to you.
Windows 98?
Yeah.
Man, that would be an upgrade from my mom's old system.
Ooh. Telling you, man, fix it with thermite. Yeah. So this can be a really painful lesson when you develop and test on a single machine and then deploy to a set of machines. We had a problem on the app that I work on. We had a developer that's down in Ecuador.
Yeah.
Good guy, right? And he had a box and he was pulling stuff out of source control and trying to work with our database. Well, it turns out that our app at that point was extremely chatty with the database. So it's like, oh, I need this integer. Let me go get it. Make a network call to get it. And it was making a ton of calls. Well, when you are doing that from inside the building and you're like, 7 to 10 feet away from the server, it's not as big of a deal. Mm-hmm. When you're doing it from Ecuador, it turns out that between packet loss and latency, I'll say the TCP/IP packet throughput compares favorably to that of a loaded carrier pigeon. Yeah. So, I mean, this happens.
So, I've been helping one of our senior developers kind of work on an older, much older application that is still using like C# and in Hibernate and stuff, but it's like it's before they had Fluent in Hibernate.
So like when I used it.
Yeah.
With the HQL.
Yes. Yeah. And so he's asking me questions because I'm apparently the in Hibernate expert. And I'm like, I've never worked with that. I have no idea. Here's how it works with code. Let's see what we can do. But anyways, I'm looking at some of the code that he's refactoring and like, so that's making a call and then it's looping through the results. And then for each loop, it's making 4 calls to the database.
Oh yeah, select n plus 1.
Yeah.
And you won't see those. Like you don't notice that until you're running across a network a lot of times. Like there's not a performance hit if you're not paying attention to stuff.
Yeah, and it was just funny because like I would never code like that, but back when that was written, that was like the normal, and he's trying to make it better and faster. I'm like, all right, well, we got to work on that too.
Yeah, because they didn't have the deferred execution. Like you had to build an expression up with strings.
Right. Yeah.
And I remember doing that. I mean, I've done it since actually. But even in normal operation, network calls are going to be orders of magnitude slower. And this can make things like distributed database transactions really, really unwieldy in even the best of circumstances. So if you're, trying to commit some data to one database and to another database, you have essentially a distributed transaction, right? Like they both have to succeed or they both have to fail. So you either have to have something that controls it or you have to have some semantics to go back and retry and do like distributed transactions are awful.
I've been dealing with this because it's the same database, but different schemas. And so we've got our regular stuff, but then we have our table that, our schema that kind of holds all like a record of all the transactions that go through and stuff. And so we have to write to that. Well, sometimes, again, that's through a service. Sometimes that service is down. Sometimes that, that connection is down, whatever. So we didn't want the application to fail because one of the services was down.
So you have to almost queue it to a table and go, yeah, we're going to have this other thing pick it up.
That's exactly what we did. We're saying, all right, it tries. If it fails, it tries again. If it fails so many times, then we set it over here into this table that gets looked at periodically and goes, oh, hey, there's stuff in this table. We need to move it over.
Well, it gets even more fun when you have transactions that have, like let's say that it's hitting table A on, database 1 and it's hitting table B on database 2. That's one of your transactions. Mm-hmm. Okay. They're locking. The second transaction is hitting table B on database 2 and then table C somewhere else and then table A on database 1 and locking. If C goes down, the second transaction will block the first one in the middle of its execution.
Oh, man.
While it's got the other thing locked so it can't ever get unlocked. And that's what's called a deadlock. Mm-hmm. And it's kind of hard to explain this in the air with words, right?
Yeah.
But this happens. And when you start getting distributed systems in play, you have the kind of latencies that make this stuff much more likely. Because if it's within a given database, it's a timing issue, but it's, stuff is executing so quick, most of the time you get away with it. Of course, when you don't get away with it, you're completely surprised. But, in a distributed system like this, just burns you. And you may have to restructure calls so that you reduce the amount of network overhead that you do. So like in our system, we had a lot of stuff that was like, oh, do I have permission for this? Call the database. Do I have permission for this? Call the database. And we're like, no, here's the set of permissions I need. Chuck that whole thing at the database, and the database hands me back a thing that says, here's the ones you actually have.
Yeah, and cache that in your session. You may also need to employ caching and things like content delivery networks to make this less of a problem.
Yeah, I mean, we've done stuff like using a relational model. I mean, not at this current job, but like using a relational model for the back end. But then for the front end that's real read heavy, we actually build up an object and put it in an object database or a document database, like RavenDB, for instance. Like that works really well because it serves as kind of a temporary cache of exactly the structure that app expects. So you're not having to do anything with it.
Yeah, that makes sense. So the next fallacy is bandwidth is infinite. You know, we can deal with huge amounts of data within the same machine compared to what can be dealt with over the network.
Yeah, for instance, the SATA 3 interface inside your computer can transmit at up to 600 megabits per second of actual throughput, if I got that correct. The average speed of a residential internet connection in the U.S. is 18.7 megabits per second.
Is that uploading or downloading?
That's probably down, not up.
Yeah.
4G internet is able to handle 5 to 12 megabits per second in general, but might have issues with connectivity. Like, I don't know, you walked into a movie theater or you went downstairs, like down here in the basement. The cell signal's not so great because there's concrete all around us.
Now, understand these are numbers in the United States of America. Other countries and even some parts of the USA may be far worse.
Yeah, so like my dad was in the McKenzie Mountains up in the Northwest Territories. And where he was, you don't have a cell signal. Like you gotta go somewhere to get to where there is a cell tower, and it's like, it's like 0.1 G or something. I mean, it's not,
it's the old analog.
Well, I'll just tell you this. My grandmother died at a little bit before 5 on Friday morning. We were not able to get a hold of my dad to tell him, I think, until Saturday.
And I remember he wasn't even able to get back.
Yeah, he wasn't able to get back to the funeral because of the weather coming in and everything. But
there
you
are
may have
areas
users.
like that.
Yeah, you may have users that have a really crappy internet connection, and you can't make the assumption that bandwidth is infinite. This is a problem Microsoft has had, by the way, with Windows updates, where they'll force an update on somebody. It's like, oh yeah, here's 2 gigs of crap, and this person's on a really, really slow connection that's shared with something critical, and you took some other service down. Like, you got to be careful about that stuff.
Yeah. This means that if you develop on a single machine, lots of your assumptions will be wrong when you deal with the open internet. And even more will be wrong when you deal with mobile internet, especially internationally. That's one of the benefits of working for a local government is I don't have to worry too much about internationality.
Yeah.
But we have done some mobile applications, and some of our sites are mobile, and so we've had to deal with that.
Yeah. And there's spots in Tennessee that the bandwidth is not so good.
Bandwidth also costs money.
Yeah. Sometimes the cost is really high for things like satellite internet. I mean, stuff like your text messages, right? Just the payloads and some of those. I mean, I remember reading somewhere, basically it said that the text message is the printer ink equivalent as far as, price point for moving a byte of data. It's really, really high.
That's interesting.
Compared to, residential broadband.
Yeah, that's very interesting. I remember when we were in college, I went over to the UK, and they don't have, they didn't at the time have the same cellular type service where we do, where you could buy a plan that had unlimited minutes or lots of minutes on their plan. All of their plans over there cost per minute.
Yeah.
But their home phone lines cost per minute too.
Yeah. Well, I mean, you remember when we were kids?
Yeah.
like, okay, like my grandmother that just passed, she would only call after 7. Like there's a reason she called it, 7:01 on every Thursday night for, 20 something years. It's because that's when the rate went down for long distance.
Right.
And now granted, that hasn't been true since like the early 2000s or before, but creature habit.
Yeah. But what I'm getting at is when I was over there, everybody sent text messages.
Yeah.
When we were in college, early 2000s, nobody here sent text.
It was too expensive.
Yeah. Text cost 10 cents a text or something.
Yeah, we've got a friend whose little sister ran up a $700 texting bill.
Yep.
In 2001, 2002. I remember that.
But over there...
Because I was there when her daddy found out about it. That was hilarious.
But what I'm saying is over in the UK, when I was there, it was 10 cents to send a text. But for a minute to talk, it was like 30 cents. I mean, I guess it would be pence, but
right.
It was, you get the equivalent. It was more expensive for a minute of talk than one text. And so they could send stuff via text for cheaper. So everybody texted. It threw me off. I'm like, what is this texting thing? Like it's like sending a page because, we had pagers back in our day. That's aging ourselves here, but it's like sending a page, but not quite. And it didn't make any sense to me until years later here in the States when texting became a thing because it was free.
Yeah, well,
roughly.
And it was...
Well, it was included in the cost of the plan.
Yeah, and the other thing, too, is it was easier. But bandwidth isn't infinite, and it isn't free.
Mm-hmm.
It's also possible to run into situations where your bandwidth gets restricted when you use too much.
Oh, yeah.
So, like, you peg out a Comcast connection. Now, granted, it takes a lot to do that, but they'll slow your bandwidth for the rest of the month. It's a quality of service thing. So, what happens when you have that patch that keeps downloading and doesn't work, and they keep re-downloading it?
Or, when you work from home and you don't have cable, so you watch everything on Netflix.
Yeah.
Of course, they've had to change some of their stuff because a lot of people are going to that.
Yeah.
Now, the next fallacy is the network is secure. I'm sorry. That's just...
Yeah. Well, here's the thing, right? This goes back to the whole calling semantics because you're calling stuff over the network and you're treating it like a function call on the machine, right? That's the abstraction we like to use. And the problem with that is like, yes, a call, but, inside the machine, probably secure. That's not really true either.
Right.
But they have to breach the machine at that point and, be getting memory dumps and that kind of stuff. So that's a lot harder. Whereas something going over the network, you can't make the assumption that on either end. Mm-hmm. So you got to go, hey, I'm sending this to this location. I got to make sure they are who they say they are. And when they respond, I got to make sure they were who they said they were. And they've got to do the same for me.
Right.
So back in the day, people tended to make the assumption that anything inside the firewall was secure and anything outside was not. This was back before the bring your own device days, right? Mm-hmm. You had a pocket PC that cost $600. The one guy there at the office had it. Wi-Fi didn't really work, wasn't connected. It wasn't a problem. Maybe he could plug it into his machine and maybe it might have a virus that might possibly get out inside the network, but that didn't happen a lot.
Right. Now, this started changing, though, as people brought their own devices into the mix and as you started seeing a lot more laptops.
Yeah, because your sales guy goes on the road and he's in, different clients' shops and everything else. Mm-hmm. Some virus hits his machine because his machine thinks the network is secure. The virus gets in, it lays dormant, it goes back inside your network, and then boom, it's out and it's all over the network now.
Mm-hmm. Now, essentially, perimeter security on a network, it's just not enough anymore. You have to assume that hostile parties are inside the network.
Yeah, and listening to your transmissions.
Right.
That's all there is to it.
This is something that I have done recently on one of our applications. I was explaining in our product review the other day. I was like, all right, so it was, let's say you start filling out an application, you realize, oops, I entered that wrong. Let me delete it and enter a new one.
Right.
Well, we only want to delete it if what because it saves to the database each time. So we only want to delete that row from the database if it's in the process of being entered and it's not finished.
Yeah.
So even though we're behind the firewall at this point, I still said, all right, we're going to pull the whole thing from the database and go, all right, based on what's in the database now, has this been submitted or is it still something that's kind of in progress? And if it's still in progress from what's in the database, then yeah, we'll allow you to do that.
Yeah.
But if it's already been submitted, or if it's already gone past that process, we're not going to allow you to delete that.
Yeah, you really have to have a lot of hard locks on stuff to just go, look, just because they sent you something doesn't mean you trust it. Yeah, it's just a different world. You can't assume that somebody calling your application is friendly, and you have to consider insider attacks, even if they are from a friendly workstation. Even if you can, Scott Hanselman mentioned this with talking about HTTPS.
Yeah.
Right. He says, yes, HTTPS, that proves that you are having a secure conversation. That's all it does. It doesn't prove that the devil isn't on the other end of the line. It's a transport channel thing. It's not a endpoint thing. You can have a very hostile party doing HTTPS stuff to you.
Right. All it means is that you're not getting man-in-the-middle attacks.
Right.
You're not getting someone not who you're talking to in there.
Yeah.
But that doesn't mean that the person you're talking to is who you want to be talking to.
Right. And theoretically, the certificate thing helps with that, but it's like that machine could be compromised.
Right.
In many cases, you can't assume that files or data coming from elsewhere in the network aren't malicious. So let's say there's a file that's out on a file share somewhere.
Mm-hmm.
Okay, and you're like, my app is going to read it. Well, did your app put it there? Do you have control of that server? If you didn't, that file could be malicious.
Right.
And it's very reasonable to think that. Like, you need to go full-on paranoia mode conspiracy theorist on this kind of stuff, because you'll get nailed if you don't.
This includes data that other applications put in a database that you read and execute on.
Yes. I worked on a project a long time ago where we had, and okay, I say we, this was not my idea, where we had C# code in the database. They could build their own, it was essentially building an expression tree before that was a thing. This was pre-generics. This was way back. This was like 2004, 2005, somewhere in that range.
Mm-hmm.
And they were putting C# code in the database. And then there was another app that when it was doing some of the reporting rollups, it would pull that code out, drop it into another app domain, dynamically compile it, and call it.
Holy cow.
In a different security context. And, when I saw that, I was a junior dev, but I'm like, what is this?
Yeah, no.
Yeah, it's just like, I gotta say that is like, that's like the way a parent feels when they find their kids, stash a beer or whatever.
Uh-huh.
It's just like, what are you doing?
Yeah.
And I wasn't able to get them to quit doing it. To my knowledge, that app is still in use.
Wow. On that, we'll move on to the next fallacy, which is that the network's topology doesn't change.
So a long time ago, it was reasonable to assume that the structure of the network was a constant, because it used to take a lot of work to reconfigure things. You had to pull new wire.
Mm-hmm.
You didn't have, you didn't have VIPs, like you're running a wire from point A to point B.
Yeah,
somewhere. Yeah. That's not really true now, especially with a lot of the data center network stuff. Like, they can change where packets go and how things are connected, and who gets priority and that kind of stuff.
Well, the thing is, machines are cattle.
Yeah, they're not pets.
Right. And this means that it's really unwise and really just dumb to hard code things like, IP addresses or machine names. Yeah.
Yeah. Or even the DHCP server, the DNS server, that kind of stuff. Like, you can't just make assumptions. Like, you need to use the config on the machine. That also makes it a lot easier to move something into a different network. Mm-hmm. As well. Network topology changes can have an impact on both bandwidth and latency, so your apps need to take this into account at runtime.
Latency could change if, say, for instance, the main connection fails and a secondary connection is brought online just to keep the system alive.
Yeah, and that happens all the time.
Yeah.
Bandwidth could change if the admins bring in new hardware or change configuration. It may be a situation where, hey, you hit a bandwidth limit because, management's trying to save money and they don't know which app is causing the problem, and you happen to be the one that hit the limitation, even though somebody else is the one that actually blew it out.
Yeah, you were the straw that broke the camel's back.
Yeah.
What this makes me think of, and this is a good example here, is we have a certain amount that we are allowed to upload on our CDN for the podcast. I think it's like 250 megabytes.
I don't remember.
Yeah, so it's something like that. Let's say it's 250 megabytes. But because of the way that our CDN is built, it's a really great sales model where they give you kind of a buffer. It's like, all right, we pay for 250, but if you go 50 over,
yeah, they let it slide.
And
that's partially because of the way the calendar works, because it's monthly, and it's like, well, if you do a weekly podcast, sometimes you have 5 and sometimes you have 4.
Right. Exactly. And so this past month, I uploaded, because the episode came out on the 1st, I uploaded it on the 31st.
Right.
And we hit that limit. We got an email that said, hey, your grace
courtesy warning. Yeah.
Has been hit, and you've gone 12 megabytes over your limit, but that falls into your...
And I mean, that's a lot. 12 megabytes. I mean, dude, that's 10 floppies.
Man,
sorry.
Wow. That's an old reference.
Yeah. That's just, sarcasm.
But basically, your application needs to gracefully handle these topological changes so that it doesn't start causing problems.
Yeah. And that typically means that your app is not aware of it and is trusting the ambient environment.
Right.
To be aware of it so that server admins can do their thing.
Mm-hmm.
Instead of trying to hard code stuff and trying to be clever. Yeah. Most of the time, that's the way this works. Now, this gets really fun when something downstream of you, like a third-party service, can only handle so much traffic, but your app is only constrained by bandwidth. When the bandwidth restriction goes away, it's entirely possible for you to nuke the other service.
That makes sense.
Especially as stuff backs up.
Yeah.
I've seen that happen loads and loads of times, especially with like email service providers, where it's like, oh yeah, we've got something screwed up, and we're having major packet loss going to, I don't know, let's say MailChimp, right? Or Mandrill, they're outbound, and you're only able to get a few emails out, and then suddenly the network admins fix that thing, and there's 50,000 messages sitting back here, and they all go
at once.
It's like you flushed all the toilets in the world. That would probably break all the pipes.
Yeah.
But I mean, that's just essentially what happens. So you got to be careful about that, because it's not just you. You're not the only one here.
And that's something that I have noticed that developers don't always take into consideration, even with, say, like building enterprise level services. Like, I have seen, there are some developers I have worked with in the past that they considered as many use cases as they could think of, and they built it in such a way that it was, all right, if I missed one, it's easy to add on to it. Whereas I've seen others who built a service because they're like, oh, we need this enterprise level service that we don't have. I'm going to go build it, and I'm only going to build it for my use case, and I'm going to make it near impossible to expand. So it has to be rewritten to take on any other use cases.
The next false assumption is that there is a single administrator.
In smaller environments, there was often only a single administrator, or maybe two, like a junior-senior relationship, who controlled the entire system.
Yeah, this has gone away. Systems have gotten larger, they're more critical, and the workforce has gotten a lot more mobile and distributed. And that means that, hey, you've got to be running at 2 o'clock in the morning. It's not, the network admin will come in at 6:30 in the morning and fix whatever died overnight. Like, no, he's there right now.
Yeah. I'm just trying to think. We've got, from our operations department, we're a small division. We have 3 people that can do that role. We have one who primarily does it, and then 2 backups for him.
Yeah.
But that's just within our little division. We're also part of a larger organization that has people as well. And so it's just, it compiles up.
Yeah. So your typical modern app may have several administrators controlling different parts of the system, and they may not like each other. Any complex set of people has this, right? They may not like each other. They may not understand each other. They may not speak the same language. They may not be up at the same time. And you have to account for that in your app.
This causes you to have to think about a lot of different things. First off, you can't fail processing due to security errors. You have to gracefully handle those, because security configuration is very likely to be changed by people who don't understand your system.
Yeah, one of my favorites is like somebody writes something that, that processes a queue, right? And it goes, hey, let me try to send this one record. And when that record blows up for some reason, I don't know, maybe because there's an invalid email address, not that I'm using any examples from personal recent experience, and the whole thing fails. And the item goes back in the queue. And then the next time it comes up, it goes, oh, let me grab this item. Let me try to send it. Oh, it fails. Put it back in the queue. Oh, next time, hey, and you have Groundhog Day. That's not something you want happening. Like, it needs to gracefully fail. It needs to go to a failure queue. That has to be handled. This also means that you have to document things more thoroughly, as you cannot rely on word of mouth. You can't just go tell the admin, here's how this thing works. He's still going to be here in 20 years and remember this conversation, and there's nobody else intervening. That's absolutely not a thing anymore.
Another thing this means is that you're going to have to standardize things so that administrators can manage systems. They don't have to learn a bunch of different systems to do that.
Yeah.
It's interesting because we're going through creating standards for the newer way of developing. I started on the second team doing the .NET Web API Angular stuff when I first started at my job. And it's been really interesting as we've transitioned over. I've gotten to be part of those conversations on what standards do we need, or what are the standards for this. And it's made it easier on the operations team and the help desk team to have, all right, all the applications are like this because we have the standard.
Yeah. I mean, it really helps in a crisis too, because now you can look for things that are off. It's not off in a different way in 4 different places.
Right. Another thing too is, let's say one developer is, I don't know, on vacation, and he's gone with his new wife to Bora Bora, and there's no way to get in touch with him. You know what? Any other developer can step in there because there might be some little quirks in the way they code, but they're still using the same standards.
You're also going to need a lot more thorough diagnostic capabilities, because people are going to be troubleshooting your stuff while you're asleep, and they might be doing it a hemisphere away from you. The next fallacy is that transport cost is zero or negligible. Now, we talked about bandwidth costing money, but there's a lot of other stuff going on here too. Your utilization of a network costs money. Like, you put enough pressure on it, it's like, yes, okay, the packets get delivered, but if I'm putting enough pressure on there, eventually I've got to add more switches, I've got to do more hardware.
Yeah, even if the network is entirely owned by you, every packet that's transmitted has a cost in terms of time and maintenance to transmit it.
Yep, every packet's sacred. If you're regularly and unnecessarily saturating the network, the administrators will often want to get better, more expensive hardware to deal with the load. If you're on a cloud provider, you're often charged directly for network use, especially when it leaves the data center. Now, here's the fun thing. Let's say that you are using it in the data center and there's no cost, but some other admin changes the network topology so that now it's leaving the data center and going across data centers. Suddenly that network saturation costs money because of config change.
Now, this means that you can't ignore bandwidth costs in the design of your application. It's entirely possible for an application to work perfectly and still generate bandwidth costs that make it too expensive to be worth using.
Yeah. And I would argue at some level, Netflix has that problem in a lot of environments.
Oh, yeah. I agree 100% with that. Netflix, Hulu, a lot of
anything. If you're moving video around, even if you're moving audio around, it's not cheap.
This isn't just restricted to your internal bandwidth either. You need to be aware of what you're doing to client bandwidth.
Like, say, I don't know, on a mobile phone on the web, for instance. Even if you have stuff configured where you're not allowing caching. Because you're like, we don't want to, make our app work properly with caching, so we'll just make it so that stuff doesn't get cached. It'll beat the daylights out of a phone.
So, y'all know I'm single, and I'm looking to not be single. So I'm on a couple of dating apps. Because, in your 30s, it's hard to meet people. My ex-wife and every woman I've dated, I met through school or through people I knew at school.
Yeah.
And even though I'm back in school now, it's remote, so I'm not really in school. But that said, as a developer looking at some of these dating apps, I give a lot of feedback to them about things mostly considered, bandwidth.
Yeah. And I'm obviously not on the prowl,
yeah.
But I took Twitter and Facebook off of my phone, and the battery life and the bandwidth. I mean, I use less than 2 gigabytes of data a month on my phone.
Oh, yeah. I mean, I have my mom on my plan, and between the two of us, we use around 10 gigabytes.
Yeah, I'm less than 2.
Yeah.
I mean, I could pay for a higher plan, but I mean, I don't even use that.
Yeah. And I the thing is, I'll go sit at a bar and, eat and have a drink and play on my phone.
Yeah, I think that's the thing too, is I tend to read. I never watch video on my phone.
It's not so much video as is like, I've got fantasy football. I've got the dating apps. I'm always using like that for messaging and stuff.
And web apps they're getting really heavy, especially with all the third-party scripts. Mm-hmm. I mean, sometimes you'll hit a web page and it's megabytes of stuff, and you're like, there's a paragraph of text here.
Yeah, that's very true.
What is this?
Mm-hmm. So the final fallacy that we're going to talk about is that the network is homogeneous.
Yeah, so you can't safely assume that cost, latency, bandwidth restrictions, likelihood of network failure, etc. are the same throughout the network. Part of it might be the internal network, and you might be calling out, over the open internet to some data center.
Mm-hmm.
And, there's another part that's going over satellite internet somewhere else.
Yeah.
And those things have got different speeds. They have different failure modes. They have different ways that they tend to fail. And so you can't make an assumption across the board.
Your code may well be running in different data centers. The speed between the nodes within the data center may be fast, but the speed between data centers may not be.
And you might have clients that are occasionally or even regularly disconnected, like mobile users. You can have slow links in your architecture for various reasons, including things like, hey, turns out sometimes data centers have problems with their connections. All it takes is a backhoe.
Mm-hmm.
And there's a few things that this implies. The first is you have to code defensively around network errors, including complete failures and security issues. Now, I'll tell you this, complete failures are a lot easier to deal with than partial failures, because you got to think about what happens during a partial failure. Like, you got two pieces that both have to happen, and the first one went out and succeeded, and the second one failed. Okay, well, I'm going to roll back the first one. Oh, wait, the network partitioned between that time. I can't roll it back.
Yeah.
It gets really nasty really fast. You can't assume that any two network calls sent in order will complete in order ever. You shouldn't be assuming that anyway. I don't know why people think that would ever work, but I guess it's, when you're running on your own machine and that's the only thing, then it is kind of based a little bit closer to that. You also have to consider carefully how your application's network use might impact your clients. You don't want to saturate a critical network with requests for something that isn't critical.
Guys, this whole conversation reminds me of something that happened to me this morning. And I was on a call with my UI developer and QA. And the UI developer asked a question and then stopped talking. So I started to answer the question, and then he was mid-sentence.
Yeah.
And so I realized, oh, hey, there was, some latency there. It broke up. The network wasn't quite right. So I paused. I waited till he finished again. I started to speak and I got one word in, and then I realized he was mid-sentence.
Yeah.
That happened 3 times before I finally just gave up.
It's like two heavy-set dudes in the chip aisle trying to get past each other.
Yeah, it's just like, it was annoying, and it made me sound really, really rude when I was just trying to actually answer his question.
Yeah, for once, you weren't even trying to be rude.
Exactly. But the assumptions that we can safely make when building a distributed application are very few and far between. Unlike a lot of smaller applications, distributed applications tend not to have system boundaries in the way that many other applications have. Consequently, there are a lot of things that can cause your application to fail in a distributed system. However, if you avoid these major fallacies that we've discussed, it's a lot easier to get it right. That pretty much wraps us up. Before we close everything out, Will, what do you have for us this week for Tricks of the Trade?
Well, I'll just say to be careful about assumptions that you're making implicitly. It's okay to make assumptions, but you make them explicit. And this is a design thing in software, but it kind of applies in life too. Now, without talking about the political situation in the U.S. too much, there's a lot of that going on. There's people assuming that, hey, somebody's in the other party, they're hostile. That's not a reasonable assumption until they are proved hostile. There's stuff like normalcy bias, where you just go, hey, everything has worked this way for this long. It's going to continue working this way for this long. That sounds great until you start reading about history where all the stuff that was actually in the textbook is when normalcy bias got disrupted. Be very, very careful about your pattern matching. In other words, the way that you look at the world typically is going to be some degree of pattern matching. We look for patterns. That's what makes us intelligent, or one of the things that makes us intelligent. But you have to be aware of what those limits are, and just be very, very cautious about implicitly trusting a pattern that you think you see always be true. And that pretty much wraps us up.
Stand by for Titanfall.
If you have a question or comment, please email us at neckbeards@CompleteDeveloperPodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up for weekly emails with extra tips and insights, be sure to check out the website at CompleteDeveloperPodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with news about the show. Catch us each week as we broadcast live, talking about what's going on in the tech world and answering listener questions.
Learn more about all of our shows and groups by going to CompleteDeveloperNetwork.com, where you'll find links to Junior Developer Toolbox, Developer Launchpad, and our other communities. Thanks for listening. See you next time.